In this video, we are going to learn node point number 2 of the vector. Now, in this node point, we are going to study position vector of a point. Then, the second thing we are going to study is vector in terms of is position vector. Now, in short form, we are going to write it as PV. Okay. Number 3, magnitude. And number 4, unit vector. Now, these are all basic calculative concept of vector. Okay. So, let's all start with position vector of a point. Now, in vector we know the definition that it is a directed line segment. Okay. So, to define a point in vector, what we need to basically do? So, what we do here is all of you must be knowing to define any point on a coordinate geometry, is it not we require origin? Okay. So, can I say the position of point P is defined with respect to origin? Okay. So, now what we can do here is we will join this 2 point, and if I give the direction of the point, can I say I have defined point P, or better I defined position of point P with respect to origin, and hence this vector OP bar is called position vector of point P. Okay. So, in short, every vector can be written can be connected to origin to get the position vector, and the notation of this vector would be P bar. So, if in case I say OA bar, what is this? So, it is nothing but position vector of point A. In the notation form we write it as A bar. Okay. So, basically position vector is a vector obtained by joining the point to the origin, and the direction would be origin to that point. Now, let us study the second part, that is vector in terms of its position vector. Okay. Now, in this what I am trying to explain is, let us define a vector AB bar. Okay. So, I have a vector, let us say AB bar. Now, AB bar, the direction would be from A to B. Now, I just now said that every point has its own position vector. So, A will have A bar, B will have B bar. Now, to show that, what I do is I connect this A to the origin, and the direction would be O to A, and that is your A bar. Likewise, I connect this B to origin, and the direction is O to B, B bar. Now, if I see in this diagram, do you see a triangle in this? And if you see a triangle, can we think of a triangle law? So, here can I say by triangle law, okay, we try to follow two sides, or I better say cover two sides. Okay, the third side is the resultant if the direction is opposite. Okay, so it is OA bar plus AB bar is equal to OB bar. Now, let us put the value. So, can we write here A bar plus AB bar is equal to B bar, and that is how we got the finally result AB bar is equal to B bar minus A bar. If you just observe this very nicely, in word form, can I say any vector can be written as PV of terminal point minus PV of initial point. Okay, and that's what we should remember as a conclusion of this particular discussion. So, now on, any vector can be written as in its position vector form. So, let us take an example. If I say PQ bar, so you should say Q bar minus P bar. Likewise, if I say LM bar, you will say M bar minus L bar. Now, please remember, this can be written other way around also. If I say C bar minus D bar, you should say DC bar. Okay, and if I say A bar minus B bar, you should write it as BA bar. So, now on, we can convert a vector into its position vector form, or a position vector concept into vector form. Okay, so this is what we got as a vector in terms of its position vector concept. Now let us write vector in terms of ijk, vector in terms of I cap, j cap and k cap. Now first of all, before we start, let us understand the importance of I cap, j cap and k cap. See, basically we are studying vectors to simplify coordinate geometry only. Okay. So here what we seen is we have converted a point into its vector form by taking it as position vector. Now when we say coordinate geometry, is it not the first thought which comes in our mind is x and y axis? Now the question arises, who represent x and y axis? Then the answer is the role of x and y axis in coordinate geometry. If you understand, let us take an example. I ask you to plot a point 2 comma 3. So what you do is you take 2 on x axis and 3 on y axis, and then you get the point 2 comma 3. So is it not basically this x and y axis help you to suggest where you should take 2 and where you should take 3? So basically it is giving you the idea about the direction in which the 2 should be taken and the direction in which 3 must be taken. So the role of x and y axis here is to give direction. And if you have revised the previous notes very well, the direction of the vector is basically given by unit vector. So if I want to define x axis in vector, I will take help of a unit vector, and that unit vector is I cap. Okay. So what is I cap? The answer to that is it is the unit vector along positive x axis. Likewise, what is j cap? It is unit vector along negative positive y axis. And what is k cap? It is unit vector along positive z axis. So basically x axis in coordinate geometry means I cap in vector, y axis in coordinate geometry means j cap in vector, and z axis in coordinate geometry means k cap in vector. So whenever you talk about x, y, z in vector, you should think of I cap, j cap and k cap. Okay. Now what we are right now talking of, we are right now talking of a vector in terms of I cap, j cap and k cap. So let's take a point. Suppose I have a point x1, y1. Okay, I am explaining this with the 2-dimensional geometry, and then we will extend it to 3 dimension. Okay. Now let us show x and y axis. Okay, this is your origin. This is x1. Let's say this is y1, and the intersecting point of them is your point a x1 comma y1. Now what I want to do is I want to convert this into vector form. Okay. So I am talking of a point. So in my mind I am thinking of a position vector. Now how do we define position vector? Is to connect the origin to the point, and the direction is from O to A. Now what I can see is a triangle right now, is it not? I can see a triangle OMA, and when we say triangle in vector, we think of triangle law. But for triangle law, I need other two vectors also. So I need OM and AM. Now the choice of direction is in your hand. Whatever direction you take, it's okay. It's just that the rule has to be appropriately applied. So let me take the direction as O to M and then M to A. Now if I go by triangle law, can I say OA bar, which is a vector I want, OM bar plus MA bar. Okay, so here I can write vector A bar. Now the problem is of OM bar. We don't have OM bar. OM bar is not x1. Okay, x1 is the length. Okay, so it is not a vector. So basically, can I say right now I have given you the length of the vector. Okay, so can I say OM bar is length, which means magnitude into direction, and the direction is given by unit vector. So what is magnitude of OM? So can I say length OM into unit vector? If you see the magnitude is x1 and it is in which direction? Positive x-axis, and that's why we take I cap. Likewise, if I want MA bar, can I say it is vector is made up of two components, magnitude and direction? Magnitude matlab length, so length MA into the direction, which is given by unit vector. If you see, the length MA is y1, which is the same as the opposite side, and the direction, if you see, is along the positive y-axis, and if it is positive y-axis, it is j cap. So with that, can we write here that A bar is equal to xi cap plus yj cap. So this is the conversion of a coordinate, I better say x1 y1, sorry, into the position vector. So in short, if I give you an point A as 2 comma 3, can you convert this into its position vector as A bar as 2i cap plus 3j cap. Likewise, if I extend the same theory to 3-dimensional geometry, obviously I should add k cap. So it is 2i cap plus 3j cap minus k cap, and that is how we convert a point into its position vector. Okay. So here we have got a very basic idea about the calculation concept of a vector. Fine. Now let us discuss the next part, that is magnitude of a vector. Okay. Now in this, let us say we have 2 points A x1 y1 z1 and B x2 y2 z2. Okay. Now if you can just recall, magnitude means length and length means distance formula. Okay. So this is my first thought in my mind, that I should go for the distance formula. So if I want mod of AB bar, which is nothing but length AB, I can get using distance formula. Now all of you must be knowing the distance formula is under root of difference of x coordinate ka square plus difference of y coordinate square plus, here since it is a 3 dimension, we extend the formula difference of z coordinate square. Okay. So this becomes basically the formula for magnitude. But see, ideally when I say, just now I said that when I give you, this is just a thought. Okay. I am not going to use this as the formula to find magnitude. As I already said, whenever I give you a point, the very first thing what you do is convert this into position vector. So what I can write is x1 I cap plus y1 j cap plus z1 k cap. Likewise, b is x2 y2 z2. So I can write this as b bar equal to x2 I cap plus y2 j cap plus z2 k cap. Now what I can do with 2 points, if I ask you, can I say I can convert this into a vector? Okay. So I will try to define a vector AB bar. Now just now we have done a formula that a vector can be written as, in terms of its position vector, as PV of terminal point minus PV of initial point. Now please remember, you are not supposed to write this in exam, it is just for your reference. So with that, can I say it is B bar minus A bar? Let us put the value of B bar and A bar. So what I got is x2 I cap plus y2 j cap plus z2 k cap. Okay, plus minus x1 I cap plus y1 j cap plus z1 k cap. Now if I adjust and write, am I not going to get x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Now if you see this result of AB bar, and if you see the distance formula which I wrote here, okay, you can clearly make it out that this x2 minus x1 is basically the coefficient of I, and y2 minus y1 is coefficient of j, and z2 minus z1 is coefficient of k. That is why, rather than going for direct formula, can we write the formula magnitude of AB bar as under root of this is nothing but, I repeat, coefficient of I cap ka square. This is nothing but coefficient of j cap ka square. and this is nothing but coefficient of k cap ka square. So what is basically the formula of magnitude? Next time when I ask you, you should say under root of coefficient का square करके add. I repeat the formula. What is the magnitude का formula? Coefficient का square करके add. Okay. So under root of coefficient का square and add. This is what I expect from you as magnitude formula. Okay. So let's take an example over here. Okay. Question would be find magnitude of AB bar where A is 3 minus 1 2 and B is 1 minus 4 minus 3. Okay. Now as I said, do you see a point in the sum? Okay, and when you see a point in the sum, the very first thing you do is convert into its position vector. So what I can write? I can write it as 3i cap minus j cap plus 2k cap. Likewise, if I take the coordinates of B, which is 1 minus 4 minus 3. So what you can write B bar as? Can I say it is I cap minus 4j cap minus 3k cap. Now I'll find a vector AB bar. Okay. So what is the formula of AB bar? As I said, position vector of terminal point minus position vector of initial point. So let us subtract I cap minus 4j cap minus 3k cap from 3i cap minus j cap plus 2k cap. Please always take care of sign in this. Okay. So here I get 1 minus 3, which is minus 2i cap, minus 4 plus j cap. If you can understand, it is minus 3j cap, minus 3 minus 2k cap, which is minus 5k cap. Now can I say mod of AB bar is equal to, as I said, what is magnitude का formula? It is under root of coefficient का square करके add. So what I do is under root of coefficient का square करके add. Always write it this way so that you can always remember the formula. Okay. So what we write here, minus 2 ka square 4, 3 ka square 9, 5 ka square 25. So what I get is root 38 is the magnitude of the form AB bar. So I hope it's clear how to find magnitude. Okay. Finally, let's come to the unit vector along a vector. Now it is nothing but the extension of the discussion what we just now did. Okay. If you can recall the first note point where I said the vector is made up of two components, magnitude and direction, and the direction is given by unit vector. So if I adjust this, can I say unit vector is equal to vector upon its magnitude? Okay. So this is your formula to find unit vector. Now, in the previous question itself, if you see, is it not, here we have got the vector AB bar and here I got the magnitude of AB bar. So, vector ready, its magnitude ready. So, if you divide this two, okay, you will get unit vector. So, it is just an extension, and that is why for magnitude we never use distance formula directly, because somewhere or the other way you will be requiring the vector. So, the ideal process of getting magnitude is get the vector first and then get the magnitude. Okay. So, here just let me take one example for unit vector. Find unit vector along CD bar where C is minus 1 2 0 and D is equivalent to minus 3 5 minus 1. Okay. So, just like previous sum, let us take C, the value of C is minus 1 2 0. I will get C bar, which is minus I cap plus 2j cap, there is no k component. Next is, let us take D, minus 3 5 minus 1. So, let us convert it to D bar, which is minus 3i cap plus 5j cap minus k cap. Okay. Now what I get is CD bar, Okay, so let us find CD bar. What is the formula to find CD bar? Position vector of terminal point minus position vector of initial point. Now what is D bar? 3I cap plus 5J cap minus K cap minus of, what is C bar ka value? Minus I cap plus 2J cap. So if I do the subtraction, what I get is minus 3 minus of minus 1 minus 2I cap. 5J minus of 2 plus 3J cap. Minus K, here there is no K component, so it is just minus K cap. Now I'll get magnitude of CD bar. Now just now said, what was the formula of magnitude? It is under root of coefficient ka square karke add. See the way I am writing the values, I am reading the formula and I am writing the value. So you should always do that way if you don't want to forget. Okay, so minus 2 ka square 4, 3 ka square 9, 1, it is root 14. You got vector, you got magnitude. Okay, so your vector CD bar is ready. Okay, your magnitude of CD bar is ready, and we all know that unit vector along CD bar is vector, that is CD bar upon its magnitude. I repeat again, you are not supposed to write the formula vector upon its magnitude, directly write CD bar upon mod of CD bar. Now let's put on the values. So what I get, minus 2I cap plus 3J cap minus K cap upon root 14. Okay, so that is how we get unit vector. Fine. Now let me give you 2-3 nice examples on this. Okay, find unit vector parallel to AB bar where A is minus 1, minus 2, 3 and B is, let's say, 2, 4, 8. Okay, here if you see, there is a very fine difference between the previous sum and this sum. In this sum, they have asked us to find unit vector along the vector. You should double underline the word along. Okay, and in this sum, if you see, they want us to find unit vector parallel to a vector. You double underline the word parallel. Now, if you understand, let's say there is a vector here, AB bar. Now, what I am looking for is a unit vector, and if you recall, unit vector is any vector whose magnitude is 1. Okay, so I want to draw a vector whose magnitude is 1 and parallel to AB bar. But then if you see here, I have just said parallel. Okay, I have given you the choice of the direction. So the direction of the vector can be either along AB or it can be opposite to AB. And we all know that when we go opposite to a vector, we write minus, and when we go along the same vector, we write plus. So what's the basic change here is, the basic change is you can have unit vector formula same, there is no change. The formula of unit vector remains same. So unit vector parallel to a vector. When I say that, the formula is vector upon its magnitude, but since I have a choice of direction, I'll be writing plus or minus. Okay, so just keep this in your mind. Okay, and I would like you to write this in your note point also. Okay, so just like previous sum only, it is just you need to write plus or minus. So let's begin the question again. I got the value of A, the coordinate of A is minus 1, minus 2, 3. So I get A bar, which is minus I cap minus 2J cap plus 3K cap. Okay, coordinate of B, we have 2, 4, 8, 2, 4, 8. So B bar is equal to 2I cap plus 4J cap plus 8K cap. Now what we find is the vector AB bar. What is the formula of AB bar? Terminal point minus initial point. I am writing it directly now. What I get is 3I cap, I get plus 6J cap, I get 5K cap. Okay, so now I'll go for magnitude of AB bar. What is magnitude ka formula? Under root of coefficient ka square karke add. Okay, so what is 3 square? It is 9. 6 square 36 and 25. Okay, so 25 plus 9 is 34. 34 plus 36 is 70. Okay, so you get root 70 as the answer. Fine. So magnitude ready, this ready, but I want unit vector. So I say unit vector parallel to AB bar is equal to vector upon its magnitude but with plus or minus. So you should put a star over this result, please. Okay, so highlight and put a star. So eventually the final answer is plus or minus 3I cap plus 6j cap plus 5k cap upon root 70. Is that clear? So here two things to note when they ask you unit vector. Please always make sure is it along or is it parallel. If it is along, you will not write plus or minus, but if it is parallel, you always have a choice of plus or minus. Is that clear? Now let's twist a little bit more. Okay. In this type of sum, let's say if a bar bracket equivalent to 2 1 minus 1, b bar equivalent to 1 minus 1 0, and c bar equivalent to 5 minus 1 1, then find unit vector of a bar plus b bar minus c bar but in opposite direction. Okay. So here the keyword, if you see, find unit vector and opposite direction. So that is it. It's a simple story. Here they have given us a bar, b bar, c bar. So I write a bar as 2I cap plus j cap minus k cap. B bar is equal to I cap minus j cap. C bar is equal to 5I cap minus j cap plus k cap. Okay. Now let's find out the vector. So let us name a vector as p bar. Okay. So p bar is a bar plus b bar minus c bar. And always remember, whenever you have combination of vector, I would request you to write it separately. Okay. So here I wrote a bar plus b bar plus minus c bar. So a bar 2I cap plus j cap minus k cap. Please make sure your addition and subtraction goes smoothly. J cap minus of 5I cap minus j cap plus k cap. So what I get, 2I plus I, 3I minus 5I minus 2I cap. J minus j get cancel, minus of minus plus j. Minus k, there is no k here, minus k minus 2k cap. Okay. Now let's find its magnitude. So what I get, mod of p bar. How to find magnitude? Under root of coefficient ka square karke add. Okay. So what I get, under root of 4 plus 1 plus 4 root 9, which is 3. Okay. So that is done. So you got magnitude, you got direction, you got magnitude, you got vector. So now we can find unit vector in the opposite direction to the vector p bar is equal to, can I say, minus of p bar upon mod of p bar. So the answer is minus of minus 2I cap plus j cap minus 2k cap upon 3. If I adjust it, I get 2I cap minus j cap plus 2k cap by 3. Okay. So 3 varieties you have seen. Number 1, they will say along. Number 2, they will say parallel. And number 3, they will say opposite. If they say along, plus sign. If they say opposite, minus sign. If they say parallel, plus or minus sign. But in all the cases, the formula remains same, vector upon its magnitude. Okay. Let's take one more question. If the vector I cap plus xj cap plus 3k cap is rotated through an angle theta and doubled in magnitude, then it becomes 4I cap plus 4x minus 2 j cap plus 2k cap. Then find x. Now in this sum, the keyword is find x. So my concept says one unknown, one condition. I need one condition. If I ask you what condition you can see in the sum, you might say rotated through an angle theta. And when you say rotated, if you think of an imagination of this, let us say this is the vector and you are rotating it with an angle theta. Now, those who have done coordinate geometry very well, you might think of rotation of axis. But let me be very clear, this is not rotation of axis because they have not given us theta. Okay, they have just randomly said that it is rotated by an angle theta. Okay, so it is not the keyword for us. Now let's search, is there anything else given in the sum? So yes, they have said doubled in magnitude. Okay, so the magnitude is doubled. So what is given in the sum? Can I say, let's name the vector as a bar and b bar. So let's a bar is I cap plus xj cap plus 3k cap. Your b bar is 4I cap plus 4x minus 2 j cap plus 2k cap. What they say that your original vector when rotated, okay, it becomes double the magnitude. So I repeat, if a vector a bar is rotated through an angle of theta and double in its magnitude, then it becomes, matlab, can I say here that 2 time of mod of a bar is equal to mod of b bar. Now please don't get it wrong, 2a bar is equal to b bar is wrong. They have not said the vector becomes double. Okay, the magnitude of the vector becomes double. So there is a big difference, please remember. Okay, so with that, let us go for the magnitude formula. So twice under root of कोएफिशिएंट का स्क्वायर करके ऐड is equal to again under root of कोएफिशिएंट का स्क्वायर करके ऐड. Okay, so let's square both the side before we adjust. So, we get 2 under root of 3 square 9 plus 1 10 plus x square. On this side, do you see under root of 4 square 16. Okay, here you get 4, here you get this 16 plus 4x minus 2 the whole square plus 4 which is 20. Okay, so I'll straight away write here 20. So squaring both the side, what I get 4 bracket 10 plus x square. On this side is not 20 plus, can I say 2 common, so I get 4 bracket x minus 1 the whole square. Okay, I can cancel 4, I get 10 plus x square is equal to 5 plus x square plus 2x, sorry, x square minus 2x plus 1. I have opened the bracket. Let's arrange the term now. If I arrange it, it's not x square get cancelled, 2x on this side, 5 plus 1 4, 10 on that side, 5 plus 1 6, sorry, 10 on that side, I get minus 4. So the final result is x is equal to minus 2 and we got the value of x. Okay, so with this, technically speaking, I think so we have done some mistake in this question. Let me check the calculation. Twice of the magnitude. If you see we have made a mistake over here, let me just rewrite it again. So if we square, we get 4 bracket 10 plus x square. Here you get 20. Okay, plus if I take 2 common, I get 4. Inside the bracket, I'll get 2x minus 1 the whole square. Okay, so now let's cancel 4. I get 10 plus x square is equal to 5 plus 4 get cancelled. Let's open the bracket, 4x square minus 4x plus 1. Okay, if I simplify, 10 plus x square plus 5 plus 4x square minus 4x plus 1. Let's arrange it. If I take x square on that side, I get 3x square minus 4x. 5 plus 1 4, 3 on 10 on that side, I get minus 4 equal to 0. So 4 3s are 12, the factors are 6 and 2. Okay, so I can take 3x common. If I take 3x common here, what I get is x minus 2 plus 2 common, I get x minus 2 is equal to 0. Therefore, x minus 2 into 3x plus 2 is equal to 0. If I separate, I get x equal to 2 or x equal to minus 2 by 3. Okay, so this is where we come to the end of this particular note point. Okay, where in this note point we have studied 4 important things. Let me start. The number 1, what is position vector? Okay, so position vector is defining a position of a point with respect to origin using a vector. Number 2, vector in terms of position vector. Okay, in that what we have got, the most important part is vector is equal to PV of terminal point minus PV of initial point. Okay, that is the second note point. The third is how do we convert a vector into its position vector. Okay, so in that we knew that if a point is given, we can convert into ijk. Okay, so that is one thing. So every point has a position vector, that is the thing we have understood here. The next thing was magnitude. What is the formula to find magnitude? I repeat, this is not the formula to find magnitude where we write this. Okay, the formula is this. Okay, so you better write this and highlight it. Okay, this is the most important thing which I want you to remember. So rather than highlighting everything, I would suggest just highlight this part. Okay, under root of coefficient ka square karke add. Okay, so that is what you should understand, and then we have just followed all the sums. Okay, one more thing I forgot to tell you, in this the unit vector concept is very important. Okay, and three possibilities are there. Again I am repeating, number one is it unit vector along, number 2 is unit vector opposite, and number 3 unit vector parallel. If it is along, plus sign; if it is opposite, negative sign; and if it is parallel, we write plus or minus to the same formula which says vector upon its magnitude. Okay, so with this we end this particular note point.